So this problem is from the SAT practice test number 5, module 1, and this one has given my students a lot of trouble. So let's see, we have a function defined by f of x equals ax squared plus bx plus c, where a, b, and c are constant. So a, b, and c are all just some number that we don't know yet. The graph of y equals f of x in the xy plane passes through the points 7, 0, and negative 3, 0. So these are going to be actual x-intercepts. And this is really, really important. If a is an integer greater than 1, which of the following could be the value of a plus b? So let's write down some of the stuff we have so far. So we know a has to be an integer greater than 1, so I'll just write that down just like this. A is greater than 1. Can't equal to 1, so it's just greater than. And we know that we have these zeros. So they're going to want us to put it in this format of ax squared plus bx plus c. So what we can do is we can set up a quadratic, a binomial that'll multiply to that form. And we know that we could do that easily. So if we're going to have a 0 at x equals 7 and a 0 at x equals negative 3, we should be able to just set up something like this. So in order to have a 0 at x equals 7, we need a term that's x minus 7. And then to have a 0 at x equals 3, we need a term that's x plus 3. So this is all good and all, but here's the thing. If we look at the form they gave us for our expanded binomial, the x squared term has a coefficient on it. And the way we get that, we can just put an a right here. This is known as intercept form for quadratics. So what can we do now? Now we can just go ahead and expand this and make it start looking more like what they wanted us to. So this will work out to be ax squared minus 4ax minus 21a. So we've done a bunch of work already. What is this problem actually looking for? This problem wants to know what is the value of a plus b. So ultimately, these values right here are going to be possible values for a plus b. So let's go ahead and write that down. A plus b. A plus b equals what? Equals question mark. We don't know yet. But here's the thing. Our expanded binomial doesn't look exactly like theirs. Where they have bx, we have negative 4ax, which is to say we've actually written b in terms of a. So what we can do, so because of that, we know that b equals negative 4ax. b equals negative 4ax, or actually just negative 4a rather. And since we have that, we can actually go ahead and substitute that in for our expression for a plus b. So we can go ahead and replace that b with negative 4a. So a plus negative 4a, that is just going to be negative 3a. And now this question is giving us, what it's suggesting to us is that this is supposed to be a plus b, and a plus b is supposed to be one of these 4 values that is provided for us. So we can start testing these values. So let's go ahead and test b first of all. So a plus b is supposed to be negative 3, so a plus b is equal to negative 3a, so we just set it equal to negative 3 right here. And we'll see if we solve for a now, get a equals positive 1. Is this a solution? Well, if we go back to the very beginning, what they told us is that a is an integer and it's greater than 1. So 1 is an integer for sure, but 1 is not greater than 1. So this actually will not work as a solution. So now we can go ahead and test a, and we'll say negative 3a equals negative 6, and we'll see that a equals 2. And 2 is an integer, and it's greater than 1. And so that's why a is your solution right here. That's why choice A will work for you. It gives you an a that is both an integer and greater than 1. And it's a possible value for a plus b. Now, the interesting thing about this question is that you're not actually finding the values it has to be, just a value it could be, which is why it says, which value could it be? It turns out that a plus b could be other values if a is other values. The only restriction they put on a is that a has to be a positive, or has to be an integer greater than 1. So a could be, 3 or something like that, in which case your a plus b value would be a different number that they could have put as a different answer for this question. But of the numbers they did put, A is your only answer. Every other choice gives you a number that's either not an integer or not greater than 1. So that's why A has to be your choice.